Guys, here I am Isha Kushwaha and today I am going to explain your radar range equation. Before starting this derivation, let me quickly explain you what two types of antenna we are having. First is the isotropic antenna and second one is the directional antenna. So isotropic antenna is an antenna where a antenna radiates the power equally in an area, whereas a directional antenna radiates the power in a particular direction. For example, if I have this antenna here, so it will radiating the power in this sphere, in this spherical area equally, whereas if I have this antenna here and here is my target, so it will radiate the power in a particular direction only. So let's start with the derivation. So I taken a PT power. This PT power radiated from the isotropic antenna. So what will be the power density? Power density means power radiated divided by area. So what is the power radiated? That is PT, and area, spherical area, that is 4 pi r square, and it is given by PDI. Okay, next thing. For the radar, we are using a directional antenna. So there will be a different power density for the directional antenna, as we all know. So what I did is I multiply again, because a directional antenna has its own gain. So this G is going to multiply with our previous power density, that is PDI. So the power density of a directional antenna is given by PDD. So PT into G divided by 4 pi r square. Now as from here, it's consider this is my transmitting antenna. It transmits the EM waves to the target, and this target will reflect all the EM waves in a different directions. From one of the cross section of the target, the EM wave is reflected back towards the receiving antenna. So that cross section is given by the sigma, and it is reflected in a spherical manner only. So what will be the surface area of a sphere? Again 4 pi r square. So what we are going to do is we are going to multiply sigma upon 4 pi r square with our previous power, that is power coming from the transmitting antenna, that is PT G upon 4 pi r square is going to multiply with sigma 4 pi r square. So here I did it. PDE is equals to PT G 4 pi r square into sigma 4 pi r square. After simplification, we get PTG sigma upon 4 pi square into r raised to 4. Next thing is, as the receiving antenna not going to receive entire 100% of the power reflected back from the target, so there will be some effective aperture. What effective aperture do is, it calculating the receiving power of an antenna is the effective antenna, means how much receiving antenna can capture the power from the target. So we are going to multiply AE with the PD, means power which is coming from the targeted area. So PR is equals to PDE into AE. Now we will substitute our 4 equation in the 5th equation. So here I get my PDE, that is PT upon PTG divide by 4 pi r square into sigma 4 pi r square into AE. After simplification, I will get this PR, that is PTG sigma AE divided by 4 pi square into r raised to 4. Then I shifted this r4 at the left hand side, so and PR at the right hand side. Then what I get is r is equals to PTG sigma AE divided by 4 pi the whole square into PR raised to 1 upon 4. So this is our radar range equation. So in this so this diagram is going to this diagram is going to explain you each and everything. Initially we have a power from the isotropic antenna, that is given as PT divided by 4 pi r square. Then the power of the directional antenna, where we multiply the gain, and here the power from the target, where we multiply sigma upon 4 pi r square. In the last we multiply the receiving antenna aperture, that is effective aperture A with the PDE, and in the last we just manipulate our equation in order to get the radar range equation. So this is the oral explanation of a radar range equation. I hope you understand this derivation. If you have any type of doubt regarding this derivation, please ask me in the comment section. Thank you.